For this question, we want to determine the real solutions to the system of nonlinear equations. The system that we're working with is x squared plus y squared equals 4, and x squared plus y minus 1 squared equals 1. But before I start solving this question, I really like to get a visual representation of what's going on. And when I get that visual representation, it gives me an idea of how many real solutions I might have. So when I look at these two equations, they're following the format of the equation of a circle. The equation of a circle will look like this: x minus h squared plus y minus k squared equals r squared. And both of them follow that pattern. The first equation would have a center of 0, 0 with a radius of 2, and the second one has a center of 0, 1 with a radius of 1. So if I can sketch two circles in the same plane, I'm going to get an idea of how many intersection points I might have. So thinking about drawing two circles in the same plane, I could have, a circle and another circle like this. So I might get two intersection points. I could have the two circles just sort of touching each other like this. I could have the circles being the same circle, and then that would be infinite intersection points. I can definitely tell that these are different circles, so it's not that one. And the two circles could be totally separate. In that case, we would have no solution. And that's all I can think of at the moment, but if another option comes up, I'll draw that. So looking at these options, I could have two solutions, one solution, infinite solutions, or no solutions. So I'm looking at how to solve this equation, and I'm thinking about my methods of either substitution or elimination. And with the substitution method, I would be solving for one variable and substituting into another. And I can see that I could solve for x squared and substitute into x squared. And with the elimination method, I also can see that I could eliminate that x squared. So I think either method would be a good one. Let's try it with substitution. So I'm going to take that first equation and solve for x squared. So I'll subtract y squared on both sides. That gives x squared equals 4 minus y squared. And then I substitute that into the other equation. So when I substitute into the other equation, that would give 4 minus y squared plus y minus 1 squared equals 1. Now I have an equation with only the variable y in it, and I'll try to solve that. To solve it, I want to get rid of all these parentheses and combine like terms as much as possible. So that means I will write y minus 1 squared as y minus 1 times y minus 1. Multiply that out to get y squared plus, that will be a minus y plus 1 equals 1. I'll start combining like terms. The minus y squared and positive y squared cancel each other out. The minus y and minus y combine together to be minus 2y. The positive 4 and the positive 1 combine together to be a 5. And on the other side of the equation, I have a 1. So I'll solve this by isolating the y. I'm going to subtract 5 on both sides. That's negative 2y. equals -4. I'll divide both sides by -2, and that gives y equals +2. So this only gives me the y-coordinate, and I want to find the x-coordinate as well. Solutions to systems will be ordered pairs. So I'll substitute this y equals 2. I'll substitute this y equals 2 in for y. If y equals 2 and x squared equals 4 minus 2 squared, that's 4 minus 4, which is 0. X squared equals 0, so that means x equals 0. I have the ordered pair 0, 2 as the solution to this system. I'm going to check in a couple different ways. I'm going to check by actually drawing the graphs of these circles, and then I'll check the algebraic way by seeing if this ordered pair is a solution to both systems, or both equations in the system. So to check graphically, I would draw each circle, a circle centered at 0, 0 with radius 2 would give me a circle that looks like this, and then a circle centered at 0, 1 with radius 1. Let me draw that in a different color. Centered at 0, 1 with radius 1 would be this circle right here. And you can see that these two circles would intersect at this point, which is 0, 2. That's the solution that we have. Then to check it algebraically, checking is always a good idea when questions come up on a test. Make sure that you don't make any simple arithmetic mistakes. So let's check 0, 2. In the first equation, that would give 0 squared plus 2 squared equals 4, and 2 squared does equal 4. In the second equation, that would be 0 squared plus 2 minus 1 squared equals 1, and 2 minus 1 is 1 squared, which is 1. So this ordered pair does work in both equations in this system, and we have our solution being the ordered pair 0, 2. For this question, we were given the graph of a quadratic function that you see on the left. And we want to answer the following questions. We want to state what the vertex is as an ordered pair, state the domain in interval notation, state the range in interval notation, and state all intercepts as ordered pairs. So we're going to start with the vertex. Now the vertex of this graph will be this point right here. We can think of it as the bottom of the valley. If it were a down-facing parabola, it would be the top of the hill, top of the peak. So I can read the ordered pair from the graph here. It has an x-coordinate of 1 and a y-coordinate of 4. So the vertex of this quadratic function is the ordered pair 1, 4. The next thing we want to find is the domain of this quadratic function. Now we're going to assume that these are arrows going on forever. And if we use our ruler, we can take a look at holding that ruler vertically. And when we're holding the ruler vertically, what we're paying attention to is that vertically it's marking out different places along the x-axis. And that's important because the x values are what makes up the domain of a function. So when I'm holding this ruler vertically, I'm going to sweep it from left to right and pay attention to when my ruler starts hitting the graph and when it stops hitting the graph. So because of these arrows going on forever, it's going to keep going up and to the left and up and to the left. That means that there is no real starting point for the domain. We say that it begins at negative infinity. And because of this arrow here, it's going to continue to go up and to the right. There's no stopping point for the x values. So it goes from negative infinity to infinity. That's all real numbers. For our range, we'll hold the ruler horizontally. And when we hold it horizontally, this is marking out different places along the y scale, which is important because the range marks out the y values that are on our function. So we notice that down here at the bottom, we don't have any piece of the graph. So the range is not going to start until we get to that vertex. Remember that vertex was at a y value of 4. So that's where our range is going to start. And this point, the vertex, is on the graph, and that means 4 is going to be included in the range. And so we put a bracket on the 4 to indicate that 4 is in the set. So 4 would be the lowest y value, and then because of those arrows continuing to go up and up forever, we have no stopping point for the range, so we mark that as infinity. So our range goes from 4 to infinity, including 4. Then finally, we want to state all intercepts of the quadratic function. So we have x-intercepts and y-intercepts. X-intercepts are where your graph crosses or touches the x-axis, and y-intercepts are where the graph crosses or touches the y-axis. So I'm taking a look at my x-axis to see if the graph ever crosses or touches the x-axis. You can see that the graph is well above the x-axis and never crosses or touches it. So we have no x-intercept. We'll do the same thing for the y-axis. So for the y-axis, I'm going to take a look and see if the graph ever crosses or touches the y-axis. You can see here the graph crosses the y-axis at a value of 5, and we'll write that as an ordered pair. That is 0, 5 for the y-intercept. Consider the quadratic function below. Graph the function using transformations. We have the function f of x equals x minus 7 squared minus 9. Now we've already been told that this is a quadratic function, but if we weren't told it's a quadratic function, you would notice the squared, and that would indicate what your base function is. So our base function is y equals x squared, call that the square function, and the graph of the square function has a parabola which has a vertex at 0, 0. Now this is important because we're going to transform this graph by shifting or reflecting or stretching and compressing. And if we know what the graph starts looking like, it's going to help us to understand what to transform to. Now looking at this example, I can see two transformations. We've got this minus 7 and minus 9. Maybe I should put those in different colors. So the minus 7 and minus 9, they are both in the category of shifts for this transformation. And the reason why I know they're shifts is because shifts will happen whenever you add or subtract to your base function. So we have -7, that's subtracting, and -9, subtracting, and so I know that I have shift. Now there are two types of shifts. You can have a vertical shift, which means that you're shifting up or down, or a horizontal shift, meaning you're shifting left and right. And we can distinguish between those two types of shifts based on where the adding happens. So if we focus on this squared, we can see that this -7 happens inside of the squared versus the -9 happens outside of the squared. Or in other words, the -7 is affected by the squared where the -9 is not affected by the square. So whenever we have whenever we have adding or subtracting that is inside the base, inside the square, we know that that is a horizontal shift. And whenever we have one that is not affected by the squared or outside the square, it is a vertical shift. Now, once we know that it's horizontal and vertical, we want to know which direction. Horizontal could be left or right, vertical could be up or down. So the minus or plus is going to indicate whether you are going left or right and up or down. So with a horizontal shift, if you have a minus, that means you're going right. And with the vertical shift, if you have a minus, that means you're going down. So we're going to go right 7 and down 9. So what I'm going to pay attention to is that 0, 0, where the vertex was that we talked about earlier. If we take that point of 0, 0 and shift that point to the right 7 and down 9, that's going to get us to the new location of our vertex. So we start at the vertex, go to the right 7, go down 9, and that is the new location of our vertex. We started out having an up-facing parabola, we'll continue to have an up-facing parabola. You would only turn it into a down-facing parabola if you had a reflection, which would be a negative. So we have an up-facing parabola, and that is the sketch of our quadratic function. The diagonal of a TV set is 39 inches long. Its length is 21 inches more than the height. Find the dimensions of the TV set. Make sure to show all your work to receive full credit. So on this example, we're talking about a television set that's going to be in the shape of a rectangle. And we're told that the diagonal of the TV set is 39 inches long. And the diagonal goes from corner to corner. I'm going to label this side as the width and this side as the length. I typically put whatever side is longer as the length. And then we have a statement here that says the length is 21 inches more than the height. So maybe I should call this the height instead of the width. The length is 21 inches more, 21 inches more than the height. And we want to find the dimensions of the TV set. So I can label this length with height plus 21. And then as I look at this, I can notice that if I look at the length and the height and the diagonal, that creates a right triangle. And a right triangle can be used with Pythagorean Theorem. So Pythagorean Theorem is when you have a right triangle and you have two sides. We call those the legs. And then the side that's opposite the right angle, we call that the hypotenuse. And Pythagoras says that there's a relation between these sides, and the relation is that a squared plus b squared equals c squared. So we can use that relation that we have in our picture. 39 will be the hypotenuse because it's opposite of the right angle. So we have h plus 21 squared plus h squared equals 39 squared. So if we're able to solve this equation, we'll know the value of the height and then ultimately know the value of the width, the length. So let's work this out. We need to do h plus 21 times h plus 21 plus h squared equals 39 squared. I think I might need my calculator to help me with these big numbers. So 39 squared is 1,521. I'll multiply this out. H times h is h squared. H times 21 is 21h. We have another 21h. And then we need 21 times 21, which is 441. I carry down that plus h squared, and this equals 1,521. I'll combine like terms. H squared plus h squared will be 2h squared. 21h plus 21h will be 42h. And we have 441 equals 1,521. So I can see now that I have a quadratic equation. I'll subtract this 1,521 on both sides so I can move all the terms to the same side. So 1,521 minus 441 would be 1,080, and that should be negative. We have 2h squared plus 42h minus 1,080 equals 0. I want to try to solve this quadratic. I'm going to start by solving it with factoring, but if I'm not able to factor, I will try to use the quadratic formula. Quadratic formula always works. So first I notice that all of these numbers are even, so I can factor out a 2. That would give h squared plus 21h minus 540. And then I'm going to look for factors of 540 that could create a 21 in the middle. So let's look at 540. That's 1 and 540. 2 and 2 goes into there. 270. 3 goes into there. I'm going to use my calculator to help. 540 divided by 3 would be 180. 4 will go in there. 540 divided by 4 will give me 135. Okay, it ends in a 0, so 5 will go in there. 540 divided by 5 be 108. None of these get me anywhere close to 21 so far, so I've got to keep going. Let's try 6. 540 divided by 6 would be 90. I don't think 7 would go in there, but let me try it anyway. Okay, 7 does not go in there. I don't think 8 will. How about 9? Yes, 9 will. 9 times 60 10 times 54, and then I don't think 11 does, about 12, 540 divided by 12 is 45. And let me subtract those two. 45 minus 12 does not give me 21. So let me keep going. I don't think 13 works, but let me double check. Okay, 13 does not work. 14 won't work. 15 might. Let's try 15. So 540 divided by 15 is 36. 15 times 36. And 36 minus 15 does give me 21. So there's the pair I was looking for. So let's factor this into H and H. 15 and 36. I want the positive on the 36 and the minus on the 15. I can then set each one of these factors equal to 0. And that gives H equals 15 and H equals negative 36. Remember, H stands for the height, so having a negative height doesn't make sense. So this is our solution of having a height of 15, and then the length will be 15 plus 21. That's going to be 36. So the dimensions of our television set will have a height of 15 and a length of 36. So that is the dimensions of our television set. Length, 36 inches, height of 15 inches. How long in years and months will it take for an investment to double at 8% compounded monthly? In the wording of this question, it mentions compounding monthly, and that is some keywords that will indicate which formula I'm going to be using. Because it's compounded monthly, that means periodically interest will be compounded or added into the account. So we're going to be using this formula, A equals P times 1 plus R over N to the NT, where P stands for the principal initial investment, R stands for the interest rate, N stands for how often that interest is compounded or added into the account, and T is time in years. And then finally, A is our accrued amount. So when you first glance at this problem, it seems like they don't give you enough numbers or information to work it out. The only number we see here is the 8%. So that 8% is the R, the interest rate. And we're going to use that 8% in decimal form. However, some of the other information in the problem will indicate maybe not values for the variables, but relationships between the variables. We're looking for the doubling time, how long it will take for your investment to double. So the question asks how long, so we know that this is going to be our missing value that we're trying to solve for. And the fact that we're looking for how long it takes to double is going to give us a relationship between our starting amount and our ending amount. We know that our ending amount should be twice the starting amount. So although we don't have numbers to put in place of the principal or the accrued amount, we do have that relationship between those two variables. In addition to that, we have that the interest is compounded monthly, and that is 12 times in a year, and that gives us the value of N. So n is 12. So with this information, I'll substitute everything I have into this formula. So once again, that formula is A equals P times 1 plus R over N to the NT. A is going to be twice the initial investment, twice the principal. Then P, we'll just write that down. The interest rate is 8%. We'll use that in decimal form. N is 12. N is 12 and T is our unknown. As we begin to solve this, we would want to isolate the exponential. And the exponential is this portion right here. So to isolate it, we would divide both sides by p, and those p's cancel out on each side of the equation. That leaves me with 2 equals 1 plus 0.08 over 12 raised to the 12t. So now you can see that the only variable I have is t. So I'm going to use my calculator to simplify what we have in the parentheses. And I'm pulling that calculator up now, so I apologize, it takes a moment. So we'll type in 1 plus 0.08 divided by 12. And that gives us 1.006 repeating. Okay, so that is a repeating decimal. Let's see what that is as a fraction. I get math, frac, so convert it to a fraction, 151 over 150. I think I'm going to write it this way because if I write it as a decimal, it's going to round, and I prefer not to round until I get to the end. So I'm going to write 151 over 150. So now what I have is an exponential equation, and to solve the exponential equation, I'll take the log of both sides. Do the log on the left and the log on the right. I have a power rule for logs, which allows me to move this 12t in front of the log as the coefficient of the log. And then I'll solve for t by dividing both sides by 12 natural log of 151 over 150. So I have t equals natural log 2 over 12 natural log of 151 over 150. I'm going to pull up my calculator again and type that expression into my calculator. Natural log 2 divided by, and I need parentheses around my whole denominator, 12 times natural log of 151 over 150. Close parenthesis for the log and close parenthesis for the denominator. So that gives me 8 years and some change, 8.69 years. But if you'll notice when we read the question, it says we want to put the time in years and months. So we know it's going to be 8 years. Let's figure out the months. So let me take away those 8 years. And I'll convert the years to months by multiplying by 12 because there's 12 months in a year. And so it will be 8 years and 8 months. And I'm actually going to round up to 9 months. So 8 years, 9 months. During a research experiment, it was found that the number of bacteria in a culture grew at a rate proportional to its size. At 6 a.m., there were 2,000 bacteria present in the culture. At noon, the number of bacteria grew to 3,200. How many bacteria will be there at midnight? So when we take a look at this, we're using something called population growth or decay. In this case, the bacteria is growing. It was at 6 a.m. 2000, and then it grew to 3,200. So it's growth and not decay. Whenever we have a growth, our K, our rate, is going to be positive. So in this problem, we need to establish what the value of K is, what the growth rate is. And we're going to use this information about the size of the bacteria population at 6 a.m. and the size of the bacteria population at noon. So let's write this down. At 6 a.m., we have a population of 2,000, and then at noon, the population grew to 3,200. Now what I need to know is the time difference between these two, noon and 6 a.m. So 6, 7, 8, 9, 10, 11, 12, that's 6 hours later. So for a time of 6 hours, it grew to this amount. Now with that information, what I'm going to be able to do is I'm going to be able to establish this as my beginning, t equals 0, this as t equals 6, and then I'll be able to solve for k, the growth rate. So with my formula, P of t equals P naught e to the kt. P of t will be 3,200. P naught, the initial amount, that's going to be the 2,000. K is my unknown, and 6 hours later. So we started at 2,000, after 6 hours grew to 3,200. Okay, so we're going to solve. We're going to divide both sides by 2,000, which that reduces to 32 over 20 equals e to the 6k. I can reduce that even more. 4 goes into 32 8 times, 4 goes into 25 times. We can take the natural log of both sides. I forgot to do it on the right. And natural log and e, these are inverse operations of each other, so they cancel each other out, and you're left with 6k. And we can divide both sides by 6. So this is going to give me the value of k, the growth rate. Natural log of 8 over 5 over 6. Once I know the growth rate, I'm going to be able to answer the question. How many bacteria will be present at midnight? So how much time are we talking about there? So we have 6 a.m. to midnight. So that's going to, I know that 6 a.m. to noon was 6 hours. And then to midnight will be another 12. So I know I have 18 hours that I'm talking about. So my P of t will start at 2,000 at 6 a.m. I've got the K, the growth rate, natural log of 8/5 over 6, and then my time. So I can plug in a time of 18 to answer this question. So I'm going to type this value into the calculator. Got 2,000 E. I'm going to put that 18 first. 18 times natural log of 8/5 divided by 6. So that population grew to 8,192 bacteria after 18 hours, so by midnight. Thank you for checking out my videos. Have a great day.